Welcome to this quick explainer where we are going to absolutely break down a full 10-mark exam question. I'm going to show you exactly how to get every single point.
So here's our game plan. We're going to walk through the entire question piece by piece. We'll look at the basic physics, crunch some numbers, and even get into the nitty-gritty of what examiners are looking for.
All right, let's dive in. Our challenge is question 2 from the GCSE Physics higher tier paper, all about nuclear fission. The mission? To figure out how to bag all 10 of those precious marks.
The question kicks off with this diagram right here. It's showing a uranium atom splitting apart, and this single image is pretty much the foundation for everything that's about to come. So what's the real secret here? It's not just about remembering the physics. It's about playing the game. It's about understanding what the person marking your paper wants to see. Precision, showing your work. That's the stuff that gets you the points.
Let's get into the first part of the question. This is a classic fill-in-the-blanks task, worth 3 marks, and it's designed to check if you've got the fundamental ideas down.
Okay, first sentence. It's asking where the energy actually comes from in that uranium atom. Is it the whole thing, the electrons whizzing around? Let's see what the mark scheme demands.
And there it is. The keyword is nuclei. Not atoms, but the very center. Being that specific is what gets you the mark. It's a small detail, but it's a crucial one.
All right, next up, the question points us back to the diagram and asks about those 3 little particles that come flying out after the split. What are they?
Yep, those 3 things are neutrons, and that's exactly what you need to write for the second mark. These are the guys that can go on to smash into other uranium nuclei and cause a chain reaction.
And for the final blank, we know fission releases particles and energy, but it also lets out a burst of electromagnetic radiation. But what kind? There are lots of types.
The third and final mark here goes to gamma rays. It's that super high energy radiation. So there you have it. 3 simple fill-in-the-blanks, 3 very specific answers, and that's 3 marks in the bag.
Okay, let's switch gears and get into the math. This is where showing your process, your working out, becomes absolutely essential. We'll start with a nice, simple formula recall.
For just 1 mark, all you have to do is write down the right equation. This should be in your equation sheet, so it's really just a test of whether you can find it and copy it down correctly.
And there you go. Energy equals power times time. The mark scheme will accept it written out in words or just with the symbols. E equals P times T. Simple as that. A very easy mark to pick up.
Now for the bigger calculation, this one's worth 3 marks. They've given us power and time, but you gotta be careful. See that little M next to the W? That stands for megawatts, and that's a classic trap.
So let's break it down. Step 1, and you can't skip this, is to convert 500 megawatts into plain old watts. That's 500 million watts. Step 2, you plug that big number and the time into our equation. And step 3, you just punch it into your calculator. Each step could be worth a mark.
The final answer is a ginormous number, 1.8 trillion joules. You can write it out with all the zeros, or you can use standard form, like you see here. But listen, here's the best part. Even if you mess up the final calculation, if you showed you knew how to convert the units and substitute them correctly, you can still get partial marks. Showing your work is your safety net.
Okay, next part. We're moving away from the physics inside the reactor and onto a massive real-world problem. What on earth do we do with all the dangerous radioactive waste that's left over?
Now, check out the wording here. Suggest 1. When you see the word suggest in an exam question, it's a huge clue. It means there isn't just one single perfect answer. They'll accept a few different sensible ideas.
And here's the proof. These are all acceptable answers, straight from the mark scheme. You could say you bury it deep underground, or store it in cooling ponds, or even encase it in concrete. Any one of these gets you the mark.
We're on the home stretch now. For the last part of this question, we've got a nice, clean 2-mark percentage calculation. Let's see how those 2 marks are actually awarded.
The task is pretty simple. What's 92% of a year? Now, the first mark is for showing how you're going to do the calculation, and the second one, of course, is for getting the right answer.
And check this out. This is another great little exam secret. The exact answer is 335.8. But notice what the mark scheme says. It says they'll also accept 335 or 336. They know people might round to the nearest whole number, and that's perfectly fine. That's a real confidence booster, isn't it?
So, we did it. We've gone through that whole question. But what are the big lessons here? how can you take what we've learned and use it to ace other questions?
Okay, let's sum it up. First, precise language is everything. Saying nuclei instead of atoms is what separates a good answer from a great one. Second, always show your work and calculations. It can save you. Third, remember that suggest questions give you options. And finally, be a hawk when it comes to units. That NW to W conversion was a make-or-break moment.
Honestly, if you can start applying these strategies, if you can think like the examiner and know exactly what they're looking for, you can tackle these big, scary questions with way more confidence. You're not just answering the question anymore, you're actively securing every single mark.